Hello, I'm Andrew from Team 11311 Paragon, and this is our NorCal Regionals Control Award video. To better adapt to the capabilities of our alliance partners in Autonomous, we have two strategies. In our first strategy, we first score the preloaded freight onto the designated level of the alliance shipping hub, and then we go and pick up and then score 3 more freights onto the third level of the alliance shipping hub. To move quickly but also reliably enough to score freight in Autonomous, we use Roadrunner, a library that tells the drivetrain at any time what position and velocity it should be at in order to get to a target position. Finally, in the end, we will park fully inside the warehouse. Our second strategy, which we employ when our alliance partner can score more freight than us in Autonomous, we first deliver the duck from the carousel. Then we score the preloaded freight onto the designated level of the Alliance shipping hub, and then finally we park in the Alliance's storage unit. This year, we made effective use of many different sensors. While we do use encoders to control the velocity of our drivetrain and the position of our lift, the most important use of encoders on our robot is on our 3 odometry wheels. Taking the encoder inputs from our 3 odometry wheels, as well as an initial starting position, we are able to accurately track all 3 degrees of movement possible for the drivetrain in Autonomous. This allows for us to compensate for any discrepancies between the robot's target location and its actual location, making our Autonomous code more reliable and more robust. To determine the position of our team shipping elements in Autonomous, we use a USB camera as well as our own custom OpenCV detector. Taking the frames from our webcam, we first convert them into YCB-CR color space, CB for the blue side and CR for the red side. Then, for each position on the barcode, we take the average CB or CR value depending on the side, and we deduce that the position with the lowest CB or CR value is also the position that the team shipping element is on. On both of our intakes, we use Rev 2 meter distance sensors to detect when freight enter and exit the intake buckets. When a piece of freight enters the intake, it will automatically retract and spit the freight back out until it has exited. We use a magnetic limit switch to detect when the lift is fully retracted, allowing us to rehome the lift during teleop when needed. Lastly, we use the control hub system clock to time certain movements, such as having our intake start running after it has fully extended. To automate the movement of the lift and outtake in teleop, we use a complex state machine. This state machine uses 5 outtake states, 4 hub levels, and 2 lift modes. In the first state, the lift and arm are fully retracted, ready to pick up a block from the intake. In the second state, the freight is grabbed and the lift and arm start extending. In the third state, the lift and arm are fully extended. The position of the lift and outtake at this state is determined by the hub level set by the driver. In the fourth state, the freight is dropped. In the fifth state, the lift and arm retract, and then we are finally back at the first state.